Welcome to my channel Infinity Learn Mathematics in a Simple Way. So today we are going to learn the derivative, one of the most important concept for the point of your examination. So first theory is the what power for every topic of mathematics. So try to understand the basic theories first of all, then you can solve the easily exercise problems and whatever problems that may appear in the exam. So first of all, try to understand the meaning of derivative. A function y is equal to f of x is said to be a function. Let's write down. Listen carefully. A function y is equal to f of x is a differentiable at a point if a limit of delta y by delta x as delta x tends to 0 exist at that point. So once again, listen carefully. A function y is equal to f of x. Listen carefully here. A function y is equal to f of x is a differentiable at a point if, when it is going to be differentiable, if limit of delta y by delta x as delta x tends to 0 exists at that given point, we can say then the function is said to be what? Derivable or differentiable. For a differentiable function, dy by dx, derivative of y with respect to x is dy by dx. For a differentiable function, dy by dx is equal to limit of delta y by delta x as delta x tends to 0 or delta x tends to 0 is called as what? Dy by dx. It is denoted by the derivative of the function y is denoted by what? Dy by dx. That is equal to what? Limit of delta y by delta x as delta x tends to 0, or equivalently we can say that, or equivalently f dash x, instead of dy by dx we can denote the function in terms of f of x, and its derivative is what? F dash x limit of delta x tends to 0 f of x plus delta x minus of f of x divided by what? Delta x. F dash x is equal to limit of f of x plus delta x minus of f of x divided by delta x as delta x tends to 0, or f dash of x is equal to limit of h tends to 0 f of x plus h minus of f of x divided by what? H. So this is what the concept of derivative. Once again, try to understand the derivative, meaning of derivative. A function y is equal to f of x is a differentiable at a point if limit of delta y by delta x as delta x tends to 0 exists at that point. For a differentiable function dy by dx, limit is equal to what? Limit of delta y by delta x as delta x tends to 0, or equivalently we can say that f dash x is equal to limit of f of x plus delta x minus of f of x divided by delta x as delta x tends to 0, or f dash x is equal to limit of f of x plus h minus of f of x divided by h as h tends to 0. Now come to the what? Let us try to understand what is differentiation. What is differentiation, the process of the process of finding the derivative of the process of finding the derivative of the given function, the process of finding the derivative of the function or given function is called as differentiation. Wait a minute, I did the mistake here in the writing. Sorry dear students. The process of finding the derivative of the function is called as what? Differentiation. For a function y is equal to f of x, derivative of derivative with respect to x is denoted by for a function y is equal to f of x, the derivative of the function with respect to x is denoted by dy by dx or y1 is first derivative, or y dash or f dash of x if the function is given, or f dash x. So once again repeat, the process of finding the derivative of the function is called as what? Differentiation. For a function y is equal to f of x, derivative with respect to x is denoted by dy by dx or y1 or y dash or f dash of x. Now let us try to understand the rules of differentiation or derivative. We can say first one, derivative of a constant is always 0. The first rule, derivative of constant is 0. So this statement how we will write in the mathematical form, that is derivative of k with respect to x dx is always 0 where k is constant, where k is what? Constant. So remember, derivative of constant is what? Always 0. In the second rule, if k is a constant, then derivative of k into f of x with respect to x is equal to what? K into d by dx of f of x. It means if constant and function will appear together in product form, at that time keep the constant k as it is. Listen here and see, observe here, it is there. Here k is constant and f of x is what? Function. Derivative of k into f of x is always keep the constant k as it is, only differentiate the what? Function. So this is the what? Second rule. Now come to the what? Third rule. There, if u and v are functions, and v are functions of x, then if u and v are the two functions of what, x, then first one here, in that derivative of u plus v d by dx of u plus v is nothing but derivative of u with respect to x plus derivative of v with respect to what, x. So here derivative of sum of the two function, that is u plus v. Separate the what, these two terms, differentiate u with respect to x plus sign as it is and differentiate v with respect to x. And second one, in that only, if x and y are the, if u and v are, sorry, if u and v are the functions of x, then derivative of d by dx of u minus v is equal to derivative of u with respect to x minus derivative of v with respect to x. And the third one, that is product rule, we can say product rule here also, if u and v are the two functions in x, then the product rule is derivative of u into v with respect to x. Listen here, u is the what here, first function, and v is the what, second function. The product rule, what the product rule says here, if two functions are come in the form of product, then keep the first function u as it is, differentiate v with respect to x plus v as it is, that is second function as it is, differentiate the what, first function. Listen carefully, derivative of u into v, here u is the what, first function, v is the what, second function. If keep u as it is, differentiate the second function dv by dx plus v as it is, differentiate the first function du by dx. And the third one and the fourth one is what, quotient rule, we can say product rule. Then the fourth one is what, quotient rule. Then derivative of d by dx of u by v, this is called as what, the quotient rule. U by v means what, this is what, in the quotient form, is equal to what, always in the denominator v square, and keep v as it is, derivative of u with respect to x minus u as it is, a derivative of v with respect to x. Listen carefully once again, the quotient rule, what the quotient rule said, derivative of u by v with respect to x is what, denominator v square and v as it is in the numerator, then derivative of u with respect to x minus u as it is, derivative of v with respect to x. So derivative of v with respect to x. The next one, chain rule, we can say chain rule. And the next rule is what, chain rule. So let us try to understand what is the meaning of chain rule. Yes, if y is a, if y is a function of u and u is a function of x, and u is a function of x, then listen here once again, if y, this y is a function of u, that y is what, the function of u, and u is a function of x, and this u is what, function of x, then dy by dx is equal to, then dy by dx is equal to, what is the first function here? Y. Derivative of y with respect to u is what? Dy by du. And then what is the second function u here? U is a function of x, then du by dx. This process is called as what? The chain rule. This process is called as what? Chain rule. If y is a function of u means what? U means what? Dy by du way to find, and u is a function of x means what? We have to find the what? Du by dx, and product of these two, dy by du and du by dx, is nothing but dy by dx. This process is called as what? Chain rule. So this is all about the what? The basic meaning of the what? Derivative, and definition of differentiation and the rules of differentiation. Thanks for watching our channel. Keep watching our channel for the next video. In the next video we are going to learn the what? The formulas of the derivatives, basic formulas, and derivative of trigonometric functions and derivative of inverse trigonometric function. And after that, how to use these formulas we are going to learn in the next video. So please share my channel and like my channel and give the comments for our improvement. Thank you.